Hello. All right. Okay, I have to stand. All right. Let's start.
Yeah.
Okay. All right. So I'm Sanjay, and so I'll be doing today's workshop, which is focused on basically mastering your coding interview. So basically, your lead code and your hacker rank coding, those problems. So it's just like, okay, what happened with the project? Here you go. Oh, okay. Yeah. So let's begin. And so, what are coding interviews for? So, coding interviews are mostly focused on data structures and algorithm. And the reason why, if you see like the big MANG companies, why they focus on data structures and algorithm is because if you see like the backend structure, like if when they store data, when they so for like example, they have like millions of websites. So to store these millions of websites in an efficient way and to like access these websites, you need to have a good data structure which is complemented by a very good algorithm. So that's why like these MANG companies they really focus, especially during the interview process, they really focus on getting people like who can understand the problem and know what kind of data structure, what kind of algorithm to like implement in this problem. And so if like a simple example that we all since around, we all use the SQL, and so if you guys didn't know before, the backend part of SQL data structures and algorithm. So whenever you do a query search, it's an algorithm like a famous algorithm that is the one search in the backend to get whatever data that you're trying to search for, and and like I said earlier, it also plays a part in hiring as well. And the reason is because, like I explained earlier, and so this is code which goes around the internet. So data structures and algorithm help in understanding the nature of the problem at a deeper level, and thereby of the world. So the reason why this code is quite popular with the data structure and algorithm community is because pretty much everything that we do today is because of someone who wrote like a brilliant data structure and an algorithm complement an algorithm that works well with it. And that's pretty much why we everything like we are able to stream this live. And yeah, okay. So the language, so pretty much whenever you start your data structure and your practice session, so there is like a language that we choose. And basically I recommend like, okay, you have to use Python. But if you are like a beginner to like being like you're just starting off like doing data structure and algorithm, then I would recommend Python. But if you have like a language that you are comfortable with, like maybe Java, JavaScript, C++, then please go ahead with that, because this is all about which language you're comfortable with using and implementing that language. So by the reason I am choosing Python for, for this workshop is because it is beginner friendly, and if anyone is doing this for the first time, Python is very versatile. And the thing is like, compared to like other languages, Python you just need one kind of like of a data structure. For other languages, you have like a different way of getting the length of a particular data structure. But in Python, it's the same. It's the same function that you use, like the same method that you use for all different types of data structures. So that's one way it's versatile, and also it has a high number of built-in functions. This is very helpful when it comes to Python, because especially during interviews, they don't really care. So they say like one of the steps problem that they give you is to like sort the algorithm. They're not gonna like test you on how you're gonna sort the algorithm. They're like, okay, I'm gonna use the built-in Python function, sorting function, and then I'm gonna accomplish whatever is gonna come. But if the question, I need to know how you sorted this, then yeah, you explain it. But most of the time you want to save time, because like these interviews are like 45 minutes. So you're just gonna say like, sorting algorithm and get this done, and then I'm going to move to the next part. So that's an example of all the built-in functions that Python has, and also it reduces the bottleneck in thinking and writing your code, because, and the reason is this, Python is like a very user-friendly language. So like you don't really need to initialize any variable with like its data type or string or float. So you all you do is a is equal to something, and that's pretty much it. Python does the rest for you. So it's friendly and it's very high level language. It's pretty much easy for like beginners to like language fast and get on with the journey of Python, learning data structures and Python algorithms. So that's pretty much it from my slides. So now let's jump into the so starting off with so just before I start this, like, is there anyone who's like very new to programming? Okay. All right. So one person. All right. Sweet. Okay. So have you done Python of JS? JS. Okay. All right. Right. Okay. So in Python, um so you just say you want to declare a variable called name, and you declare it to this string here, and you don't need to specify what type of like a data, what type of data it is, or it's a string, a float, or whatever. All you do is whatever, and Python will store that inside the name variable, and so that's pretty easy, I would say. Like in other data structures, you have to like say what kind of structure you're going to save into this, but with Python, you pretty much don't have. And so I'm declaring x as hello, and y. Okay, so in Python you can also typecast it if you want to. This way, like you just say you enter 3 into it, 3 is going to be an integer forever, and it's not going to it manually. So right now, if I print that, so right now y is declared to be 3, which is type of integer, the type of y over here. So now, since we typecast it to be integer, Python says that now I'm not gonna. Oh, sorry. Can you see now? Yeah. All right. Yeah. So 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 this is basically, you can typecast it, but you don't have to typecast it in Python. And also declaring lists in Python is very simple. All you do is like list is equal to, you put 2 square brackets. That's it. You have initialized your list. But in other language, you need to like use the you need to like cast it as a list just to use a list here. But with Python, just 2 square brackets, you're done with initializing a list. And inside the list, you can put whatever you want. And it's not like the list is like typecast to a particular data type. Like you can put integers into the list. You can put it. You can put another dictionary into it. Anything, pretty much anything you want. Integers, strings, whatever you want. And so so that's list, and this is me printing the list over here. And so if this is another way you can do it if you want, but it's not necessary. You can just do the same thing. Just say uh, I do the same one, and if I print my list 1, it's going to give me the same thing. So it's pretty much the same thing. So that's how you initialize and store values into a list. And for type of y, since initially I declared it's an integer, now if I want to change it to a string, I just I redeclare the same variable. And if we check the type now, it changes to a string, because right now it knows that though initially it was an integer, after that declaration I redeclare it to be a string, and it knows that it's a string. So now when I check the type of Python over here, type of y, it says that it's a string. So that's pretty much it for the list variables. Next is conditions, which is if condition, which so here right now we know that I just redeclared y to be a string, and this condition checks if y is a string, if y is equal to 3. So 3 integer, it's not a string. So right now, if I check this, it's not going to print anything because it's not an integer. But if I redeclare that to be, so if I hash this out, so hashing is basically you're commenting that part of the code out. When you compile the code, that part of the code doesn't get run. So if I run this again, so right now it's declared to be an integer, and over here if I do my if condition again, which is checking if y is equal to 3, and this right now y is redeclared to be a integer again. And the next we have loops in Python. So we have two loops. It's pretty much the same in other languages. So we have the while loop and the for loop, and this is the basic syntax of declaring them. So here I'm declaring x is equal to 3, and so I'm saying it's while x is less than 10, and increment x by 1 in each iteration. So what happens is in the first iteration x is 3, so it gets printed. Iteration I I increment 3 by 1, so it becomes 4. So as long as it's going to keep printing it. And so I can show you. So over here we have so x is, we get it printed here, x is 4, 5, 6, 7, 8, and once it reaches 9, the loop breaks because it has met the condition that we are specifying for this while loop to break. And one thing that you must be very careful with while loops is the condition that I've highlighted here, because condition wrong, you're going to end up in an infinite loop, and that's how many programs crash. So you make sure that when you use a while loop, make sure you have like this condition where the while loop can terminate. So, and that's so that's a while loop. And for loop is another type of loop that we use in Python. So for items in range length of mylist2, so mylist2 is the one over here. So I can get each of these items in mylist2, and I can print the items in mylist2 by using this. So item over here is basically an index of the items that are stored in the list. So there's another way we can. So instead of using the index, I can also do for item in mylist2, mylist1 over here. I can also do this. So in this way, I don't have to get the index of the over here. I'm just getting the item by itself and printing it down. So if I run this right now, oh, it's not my list one, sorry, it's my list. Yeah, so if I print this now, we get the same thing. So these are two ways that you can use a for loop depending on like certain conditions that you would require. And have Python classes and methods. So Python classes is also like, so classes is like it's like blueprint you can think of. So declaring a class is like you have a blueprint of a particular object. So just say here I've used the, so you can see that Pikachu over here is the class Pikachu is a blueprint of how Pikachu. And just say I go into so once I'm declaring my Pikachu blueprint, we also have to declare like it's what its name. I mean, a blueprint in the sense it's a Pokemon's blueprint. It's not Pikachu's blueprint, but Pikachu will be built from tons of Pokemon that exist in the Pokemon world, and we need a Pikachu object that is built from a Pokemon blueprint. So for a Pokemon blueprint, what are the basic things that you would require? So you need the name of the Pokemon, you need the type of the Pokemon, and you also need that a Pokemon must have. So once I may declare my class over here, which is class Pokemon. So this is basically the Pokemon, and I have the constructor over here. So def init is in Python, def underscore underscore init underscore underscore is basically a constructor. Is something that gets created when an object of this class is called. So just say I make a Pokemon, I make out of this Pokemon class, we get this constructor gets immediately created, and you need to pass in these variables in the constructor to to create that object of Pikachu. So we have our Pokemon blueprint over here. So now Pokemon do a few things. So like the Pokemon can attack, the Pokemon can dodge, and the Pokemon can evolve into something. So methods. So methods are basically like functions that so like just say for a human example, so we have a human blueprint, and if you make an object out of me, I can do actions like walking, I I can do talking, I can do eating. So these are like methods that are inside a function. So if right now creating my Pikachu object, so Pikachu object is basically I'm getting the Pokemon blueprint from and then what I'm doing is I'm creating a Pikachu object from it. So Pikachu object is extracted from the Pokemon blueprint, and right because I have used the constructors over here. So self.name, I've used this at Pikachu, and type is electric, when it has 70. So once I do my Pokemon blueprint, once I initialize my Pokemon blueprint, uh, Pikachu object over here. And once the Pikachu object has been initialized, we have our Pikachu. So if I Pikachu, you can see that we have created a object called Pikachu, called from the class, and it is stored at this location in the memory. So one now I have a Pikachu object. So now I have an actual Pikachu object that can do stuff. So if I do Pikachu dot attack, is gonna do so is an attack. And over here we have like a specified. We just have a basic structure which says makes an attack. But since we have a right now, it can make an attack right now. It can also, if you see, if it can also dodge. So if I try. One second. What? I didn't even give it any. Okay, that's a bug. I'm not sure what's happening. Oh,
So someone's asking, is it safe to use Python type keyword?
the type keyword is basically just to see what type of data you're using to store your variable. So like the reason we don't like when you code in an actual environment, when you like do your actual Python coding, we don't use type. But the reason why we use type is because just say you ran into a bug, like how I have ran into a bug, and you want to see like, okay, why is this bug happening? So for that you can do like a type and check. So there's a if a function wants a integer as an input, and if you give it, it's not going to work. So that's where you use a type to see what type of input is going into the function, just to make sure everything goes well, and check it.
Someone is asking, does every method need self?
Oh yeah, that's true. Actually, that's what I missed out. Yeah. Yeah. So every method inside a class. Yeah. So every method inside, because self is basically like a keyword which says that, okay, I belong to this blueprint. So that's a good thing that he pointed out. So if you don't use this self keyword, this is the error you're gonna get, because Pikachu doesn't dodge. It has to dodge, but it doesn't know where it's getting it from. So we have to say self to say that, okay, this dodge belongs Pokemon blueprint. So once you declare that inside the blueprint, and when you so if I rerun, Pikachu dodges the attack. So that's a very good thing he pointed out, and yeah, so I missed out while writing my code over there. Yeah, so that's it for Python basic. I know it was fast because I had to like I also have to do the data structures part. So if you guys have any questions, you can any other questions right now.
How do you write a nested loop?
Oh,
In that case, do you just indent further?
yeah. So like if it's a nested loop, so this is our first loop. So you can just type enter and you can do another for item in
Yeah, and the layers of it is indicated by
the indentations. Yeah, yeah. Languages we have the curly brackets, right?
Yeah, here.
Yeah, here is just like so all of this colon. Once you like in any like once you press enter from the colon, it automatically gets indented inside.
Yeah, and when it comes to condition logics and stuff, is it the same? Like, how do you?
Yeah, it's the same. So like and is
Just
it's just A and B. That's it. And or is like I think in other Java it's and. But in Python it's just A and D for and for or is just or. So any other questions so far?
No, we're good. We're good.
Okay. All right. Yes. Okay. So introduction to data structures. So in data structures, we have two main types of data structures. If you see the data structure tree, we have the primitive data structures and we also have the non-primitive data structures. So the primitive data structures are like which is basically into the built into your language that you choose. So for Python, if you have like the primitive data structure, we have like data types like int, star, float, double. Like these are the things that I showed earlier. And another thing about primitive data structures is you cannot change them from what they're going to be. Use an int for a variable, they're going to remain an int forever unless you redeclare it into a different type. So data structures are primitive structures are something that a machine gives it to you and you use it in your code and you cannot change how they behave. They're going to behave no matter like if you use an int, it's going to behave like an int until you redeclare it to something else. And the non-primitive data structure that we will be focusing on today. So in non-primitive data structures, we have so these are derived from primitive data types, but we use it in a more complex way in terms of like we have so we have linear and non-linear. So in linear we have arrays, we have static, we have dynamic, and the reason why these are more complex than primitive data types is because in non-primitive data you can put in any type of data you want. Like you can put integer, you can put a float, you can put a string, you can even put another array. So that's why non-primitive data structures are basically more manipulatable. Like you can manipulate it into anything you want it to be. And that's your linear data type. And in today's session, we'll be going through linear types. So we have arrays, we have linked lists, we have stacks, and we have queues, and we have static arrays and static array and dynamic array. There are two types of arrays, which are static and dynamic. So static arrays are like arrays in Java for people who are from background. So static arrays are something that once you declare it, you cannot change it anymore. It's immutable. So if you say this array is going to be and you declare a bunch of 10 values into it, it's going to remain 10 forever. But a dynamic array is something that it can be mutated, it can be changed in size and stuff. We'll look more into that during the coding session. And yeah, an example of array where I'm trying to make it into a string. So over here, this array is basically anything. Like Python is going to take it as anything, and it's smart enough to know that okay, these are integers. So when these values, he's going to use it as an integer. But just say I want to typecast it. I don't want to use it as integers. In my use this as a string. So I can use this lambda function and map each of these item in the array into a string. So I'm using the list list function that I showed earlier, and I'm mapping each of these items. So for I in S, so for each item in the array, I'm mapping it into a string. So if I run this, you can see that initially it was all just integers, which Python understands it, and one saying that okay, I want everything to be a string. Python then says okay, since the user requested to make it all to a string, I'm going to into a string. So now if you use this in any any of your coding parts, and if you try to make like an addition with this, it's not going to work because now it will be a string only. All right, so that's it for the introduction, and yeah, next is big O notation. So big O notation is a type of a way how you measure how your performance of your algorithm. So there are basic like general ways how you measure an algorithm is like how fast it runs, like how fast it can produce. You give it an input, how fast it takes to produce a like process the input and get an output. So that's basically the time complexity. But in data structuration algorithm, we have rules to to calculate the efficiency of your algorithm. But just say I have a simple function over. So in my first function, I have so I'm just going through the range of n+1, and whatever value I enter, I'm gonna go. So whatever n value I enter, I'm gonna go through it, and I'm gonna sum it into this variable called. So that's pretty much it for this function. It's just basically a summing function for whatever n you enter. So if I enter n as 2, it's 1 plus 0 plus 1 plus 2, which is 3. Yeah. So that is 2 is the same function, but what I've done here is I've made it return into from the same it's the same function, but it's just I've redeclared it in a different way just to see how both these functions perform. So at doing the same thing, the only difference is the how they're going to do it. So now if I run function 1 and 2, and so right now I'm going to time it is a built-in function in Python. So what this function does is it calculates how long the algorithm takes to so once you given the output, how long the algorithm takes to produce the output. So if I do a time it on that, and I'll do a time it on the second function as well. Yeah, yeah. So if you can see here, the first function took 3.89 micro. Second function took 110 nanoseconds, which shows that second function process things faster than the just because of a different way I declared how it's going to work. But this can't be taken as gold standards. This depends on the processor of my computer. So if I run the same algorithm in maybe Gavin's computer, it's going to give a different results because his processor is different. The way his internal connection is different, so the result is going to be different on his computer than my computer. So we can't take this as gold standard output for like calculating how efficient your algorithm is. So that's where we have the big O complexity chart. So this chart is basically like in especially if you go in coding interviews, when you are going to solve your problem, they're going to ask like they're going to ask you, so what is the time complexity of the solution, and you need to give them an answer from this chart. And usually how it goes is usually start off with the O(n square solution. So an O(n square solution is like how you just mentioned a nested. So nested loop is an O(n square. So a nested loop, when it comes to like big data structures, it's not efficient at all. But that's the first solution to give in an interview, and from there the interviewer is going to help you like build a better solution. So log(n) or O(n), and most of the time you end up with you start off at an O(n square and in time you'll end up with you can have the same function which you did in on square, do in on, which is in a single loop, and that is by doing lead code practice, and that takes a lot of practice. But the same solution can be done in on as well. So that's how you like calculate how efficient you are in a interview. And on login is basically it's a search. So you're dividing, if you divide your data structure and you're searching one half, and if you're searching the other half, that's where you use on login. And on factorial, the worst time complexity ever. If your code is doing on factorial, that's pretty much your code is what it's doing. An example of on, an array of values, and each, just say you have an array of value of 10 sorry, n values. So for each value, what you're doing is you're checking if this value can fit in slot number 1, index 1. So if you're for n values, you're checking, you have to check for slot number 1, you have to check n times to see if this element can fit there. So once you're done with that, you go, and then you go to n minus 2. So that's n factorial, and that is pretty much a very inefficient code. And so this is the like a chart that you can easily get online. So it shows like that the for searching item in an array as on. On is basically the length of the array. So if an array is of length 10, the search is going to be O of 10, because for the best case, for your item is at the first point, it's going to be O of 1. But just say the item you want to look for is at the last position, it's going to be O of 10. And when you say big O complexity, you're always going to you're always going to say the worst case. You're never going to say the best case, because they always want the worst. What is the worst case this algorithm is going to perform? So that's why they don't mention the best case over here. They always only mention the worst case. So also one, because if you want to insert a value into an array, you have to iterate through all the values in the array to go to the end to append it into the array. And it's the same process again. And for stacks and queues, and linked lists, it's a bit different, because in stacks and queues, they don't follow logic as arrays, because in stacks you are storing you're basically storing you're just pushing on a list that is already created. You're not iterating through a list just to store a particular value. So since it's called push later. So, and the reason why it's O of 1, I will explain it when we go through the structure again. And these are some things that we will see in our other sessions, but not right now. So yeah, that's pretty much about a small description about big O complexity. And yeah. Okay, so let's start with list is a linear sequence. So linear sequence is something where, just say you have a list of items. The first item is always followed, like if the first item is always linked to the second item, and the second item is linked to the third item. So if it follows a pattern, you can see, so like 1, 2, 3, 4, they're all linked together. So that's what we call a linear sequence. So they're all in the if you see in the computer's memory, when you store an array, they are stored in the same place. And the reason why I emphasize same place, data structures where they don't store in the same place, but when you like print them out, they come out as they're stored in the same place. So they are not linear data structures, but this array over here is a linear data structure because stored together. No matter how many variables, no matter how many values you declare into the array, it's going to be stored in the same place. So for in arrays, we have two different types. We have the reference arrays and the dynamic arrays. So reference array is your reference array is used for efficiency, because just say you have an array that has multiple different data types in it. So here we have, just imagine this is 42, this is an integer, just say this is a string, just say this is another array. And if you store all this into an array, each cell is going to take different space, and that doesn't work building an algorithm, because you when you're trying to search an array, you want each cell to have the same space. So that's thought of this reference array where you have this value here. You have 42, you have 32, you have 22, and you have over here. And what you are storing into the array is just the reference of those array. Reference is basically the address of these values. No matter what value you have inside, the address is going to be the same. The address is going to be the same number of bits for any type of data that you put inside. So if you're storing the address into this, only the address into the array, and you're storing the values in somewhere in the memory, nobody cares where it's going to be in the memory, but you're only storing the address. So for the first cell, you have the address over here. You're storing the address and memory, and the second array you have the address here and the value stored somewhere in the memory. And the reason why this is helpful is because you're gonna loop through this array, it's gonna be faster because every cell in the array is gonna be having the same. So that's reference array, and next we have dynamic arrays. So in a dynamic array in Python, how it works is in Java list arrays. In Python, it's called dynamic array. So dynamic array, how it stores when you initialize a dynamic array, it stores of size 2. So over here we can see we have created a dynamic array which is of when you first initialize a dynamic array, we have size 2. So first you enter 2 into your dynamic array, and in your next step, just say you appended 7 into your dynamic array. Is full. So now what Python on the backend, what Python does is it sees that okay, this is full. I need to my array bigger. So what it does is it takes the current length of the array and it multiplies it with 2. And next stage we have 4 because initially it was 2. It takes the size of the array, multiply it through. Now we have array size of 4. Next you have 3. Python is like, okay, it's full again. I need to double the size. So it takes 4 and multiply 2, and now we have 8. So this process keeps repeating until you stop entering values into it. And so there was a question that people have, like, why increase by why multiply it by 2 instead of, like, why don't you just declare it to be a certain size and then easier, so it's not as this may look inefficient because every time it gets full, it's multiplying itself and making it. But when you see, like, this is a small array, but when you see like array which has like thousands of values in it, if you so when people did the test on declaring like a particular size and then like redeclaring the size, and then they whenever it gets full, it automatically makes its size, doubles its size. They saw that this was more efficient than just you are declaring a particular size to it. So, and this is more efficient because when you are declaring, so you have an array of 1,000 cells. When you declare that, so in your that thousand cell space, and that's very inefficient. But with this, you're not going to take any. You only have 4 values. You're going to only take those 4 values. The remaining 996 slots are free process in the memory. So that's why Python follows this dynamic array way of mutate. So to create a dynamic array, so what I'm doing here is I made my basically the blueprint of the dynamic array, and I'm declaring in it. This is the constructor. So once the blue is created, we have self.n, which is the number of elements, the count of the actual element. Okay, so they say number 7. 7 is at index 2. So self.n will be 2 for. So that is 7, and self.capacity is your size of your array, and self. Array. So what I'm doing is initially I'm setting the capacity to 1, and I'll show you why is that. So here I'm saying, so here the yeah, self make array. Yeah. So your self make array, the self put into this, And over here, this is like a ctypes.py object. It's like a built-in Python function that basically creates an array for us. And so it creates an array depending on the size you enter. So if just say if you enter a size of, so if you enter a size in, so it creates an array of size 1. That's the initial declaration. So, and then we have the resize function. So this resize function is, so we have the initial array. So this is the array that we initially made. And no, this is the initial array. And now we have B is the bigger array. So what we're doing is we're making a bigger array with the new cap, new size that was declared to the array. So the reason and then what I'm doing is, so whatever is stored in the for each item in the previous array, what I'm doing is at each position of the new array, the bigger array, I'm taking each value from the old array, the new array, and then over here, what I'm doing is I'm making the the self.a that we are going to use in all our coding later. So I'm making that into the big array that we just created over here. And the capacity, I'm also changing the capacity of the array into the new capacity. So this is just the resize function. Like, you don't really have to know does everything in the backend, but this is just like I coded this just to show that okay, in the backend how the resizing works. So yeah, so that's those are yeah, so that's the three main functions. And next, for array we have so the built-in function, one of the built-in function we have is the length of the array. So yeah, let me just, since we are short of time, I'm just going to copy paste this. Yeah, so right now I'm just returning self.n. Self.n is the sorted array. So what I'm doing is returning just the value. So over here I told you like count the actual elements. So default is 0. So over here I'm n is always at the last value. So if I do a return number of elements stored in the sorted array, so if I yeah, so over here let me declare this one second. Yeah, let's go declare it. Oh wait, I haven't put an append at the it's len. One second. Okay, so append is also like a built-in function in Python. This is basically just showing you what happens in the backend. So over here, what I'm doing is if self.n is equal to self.capacity. So over here, what is happening is, so like I told earlier, self.n is always going to be the last value. So in this case, the self.n is going to be 0, 1. Sorry, in this case, self.n is going to be 0, 1, 2, 3. It's going to be the fourth index. And sorry, it's going to be the third index. Self. So over here, I'm checking if the capacity. So for this case, the capacity is also, but and self.n is going to be, where is it? Yeah. So over here, I'm checking if the capacity has last index is the size of the array. So if the capacity has been reached, what we are doing is we are resizing the array. And like I said earlier, Python, and what it does is it multiplies its size by 2. So over here, I'm just doing a self.resize and I'm doing 2 star self.capacity. We saw that the self.capacity is 1. So now if I'm going to resize it, I'm just going to make it into 2. So size was 1. Initially the size was 1. So once we enter our first value, is going to give a size of 2. And once we have this condition is only met when the last value is equal to when the index of the last value is equal to the size of the array. And if that happens, we do a reset. But if that is not the case, what happens is we go to the last index, so which is self.a, which is our actual that we declared here, and we go to the last place and we put in our element that we enter here. So, and we also last index by 1, because we have to set this up so that the next, when you enter the next item into the, when you append the next item into the array, the n to be at the next position, not on the position where you just entered your value. Otherwise, what's going to happen is it's going to overwrite what you just appended. You have to make sure that you increment your last index by 1, and yeah, and now we are good. So we have a blueprint here, and now if I append 1, it works. Yeah. Sorry.
Like if it's 2 sizes 2, I enter 7 like
Yeah.
the second element.
Yeah.
Will it double it, or then I try to insert a new one? I'm confused.
So what happens is, so you're entering, so just say your array size is 2 now, right?
Yeah.
So your array size is 2, you're trying to enter 7 into it. So 7, once you're about it, so that's where the,
So like if the capacity is full, it won't double. But if I try to insert a third element,
Hmm.
then only it will double.
Yeah.
the code.
yeah, only when the capacity is full. So yeah, so is that your question, or?
Yeah, I was just confused that
Yeah.
are we trying to double it when we element, or if it's full, we are not trying to do anything.
Yeah, so if it's full, we don't do anything.
Yeah.
It's gonna remain full. The one comes in, it's gonna double it, because there's no point for you to like for it. It's gonna be inefficient, right? Because for the algorithm, I mean 2 doesn't make, it's not a big deal. But just say your array is of size 100, and if you're not gonna enter your 101th element, 200 size array, right? So that's why it only happens when it sees that, like in the backend, when Python sees that, okay, a new element is coming, resize it so I can accommodate the new guy coming in. So it only happens, yeah. Yeah. You understood, right? Yeah.
Popping elements off, does it kind of reduce by the same order? And let's say I have like 8 elements in there.
Yeah.
As I'm popping, resize this up to be half of it when I have.
Yeah, so what happens when you're popping it out is like once it sees that, so it works the same way in the opposite side as well. So once you're trying to take out elements, once it sees that, okay, yeah, I have reached my previous half capacity. So whenever it doubles itself, right, it creates like a memory of itself of its previous state. And once it sees that, okay, the size has been, like once you're popping it out, it sees my previous state, I'm gonna, reduce my size back. So all this happens in the back end. So I'm just I've written it and understand what's happening in the back end of every time you append something into a Python list. So yeah, so now I 1 into the list. So now if you see let's just see the size of the array right now. Okay. So the next one we have is the GetItem. So the GetItem has the in case basically the index of the item that you want to your list. So over here, what I'm checking is if not 0. So what I'm saying is like, okay, just say your array that is size of 10, and you entered an index value of 12. So 12 doesn't exist in your array. So I'm just checking that if the index that you enter is between the last item and 0. So if it is between that, if it is, we return whatever is at at that position. So in Python, if you want to item out of a particular index, what you do is you call your array, which is self.a, and you enter the index value into it. So if you want the item, you put self.a bracket 2, and you get the item at index 2. So, and here I'm checking if I'm entering, so my array size is 10, and I'm entering a value of 12 into it, I'm going to return an index error. So these are like built-in errors that are Python that says that, okay, your index is out of range, so enter a value that is within the range of your array. And if I do right, load it as a. So yeah, so now we only have, we have one value in our array. So our array's length is 2. So as we add more values into it, it's gonna, you can see the length incrementing. Yeah. So now if I check the length of the array, we are into it, and so since now right now our length of our array is 5, and so to get an item, we can do the same thing. So if I do get item over here. So since this function needs an input value, so this is the index that you need. So we have an array that 5, and just say I want to get the index maybe 2. So 2 is actually 3. We don't go 1 2 3, we go 0 1 2 and 3. So when you put 3, it's going to be yeah. Oh, I didn't run the file again. Oh, I'm not printing it this way. The reason why I didn't print out is because over here I'm just returning the size position. So if I want to see the position, I have to print it out. So if I run this again, yeah. So at the index 3, we have the element number 4. So now, right, just say I enter an index that is out of bounds. So let me just say our size is actually 5, but I've entered 10. The index you have entered is out of bounds. So that's basically an index error. So that's it for arrays. Does anyone have any questions? So okay, all right.
I have a question.
Yeah.
How is that different from just the native lists? Like implementing our own list? Like is it a normal one or?
You mean like doing this, then using? No, that's fine. Like when you implement your native list, this is
Oh.
yeah, this is just me like explaining it so that you understand, what is happening, like how an array stores value into like when you enter a value, when you get a value out of an array, like what happens in the back end of those things. Because when you implement a native list, all you do is dot get the length, but you don't know what's happening on the back end. So this is just like me explaining what's happening in the back end. Yeah.
So for tuples, it's like it's anything. It's just
Yeah, you don't have to do anything when you're actually
saved as it is.
yeah. When you're implementing the actual list, you don't have to do anything. All you doing the dot append function, which I showed you. You just keep doing Python. Everything does in the back end. Everything happens in the back end. This is just like so that you,
Like they are immutable.
yeah, tuples you can't.
It's
Tuples
just
are,
save as it is.
yeah, it saves as it is. Yeah, tuples, since they're immutable, you can't. Tuples is basically like you can think of it as a static array, because once you declare it, that's it. They're going to be the same. Yeah. So next we have stacks and queues, and we're at 8. So
Yeah, do you want to do this one and then
yeah, and then I'll do the other session, next session.
Yeah.
Yeah.
Cool.
All right. So stacks and queues. So a basic idea between stacks and queues are like they are also like a linear structure. They are also like, but the difference is how you add and remove data out of them. So if you see a stack follows a LIFO principle. LIFO is last in first out. So that basically means that whatever value you're pushing into the stack, it whatever. So just say you're pushing 2 3 4 5 and 6. Now pushing is basically the append function that you saw in list. We call it push because that's the terminology that's used in stacks and queues, and in queues is different. So in stacks we call it push and pop. So just you're pushing and appending a value at the end of the stack, and once you reached 6, just say you want to pop it. So since the last in first out is the value that you pushed in last, that you appended last, is going to be taken out first. So it's basically like how you like books on top, and then like if you want to get the book over here, you can't like I mean you can, but then like you're gonna like take the book one, book two, book through, and then you're gonna get the book at the end. So it follows the same principle as. And the top of the stack is called the base, and the sorry, the is called the top, and the top is called the base, which is like the other way around. And yeah, the implementation of a stack is very simple. So we have our stack blueprint over here, and it's initialized with the self.items. So over here, I'm just declaring it as an array, like a simple 2 square brackets. Self.items is my stack array. So let's do a push into it. Okay, yeah. So if like, since I've already explained the append function over here, I'm just, so these are like built-in functions for every list. Like Oscar just asked, what I just explained. We don't have to use anything of that. That was just to give you guys an understanding of what happens in the backend. But if you, I'm just using a dot append. That's a built-in function in Python that is going to do the same thing that I just explained. So I'm just doing which is appending a value at the end of the stack. And next we have the dot pop. So is what it does is, like, I'm taking the last value at the value, I'm just taking it out. So basically what I'm doing is I'm doing a delete. So I'm taking at the whatever is at the last index is going to, that's what pop is doing. And next we have peak. Anyone say what peak does?
Look at the top of the stack.
Sorry?
Look at the top of the stack.
Yeah, exactly. What it does is you're in your stack. You just say you want to see what is the first item in your stack that you are going to pop. See the first item, and then once you do a pop, that item is going to get kicked out. And yeah, that's pretty much it for stacks. Stacks. This is just to return the length of your stack. And yeah, so let me just initialize the stack and show a quick demo out of it. Oh, I don't have that function. It's okay. Dot push. So let me just push a bunch of values into it. Okay. So we have 12, 13, 14. If I do a s dot peak, what's going to be printed out when I print this? I'm pushing. So in this logic, if you see, if I'm pushing 12, I'm pushing 13, and then I'm pushing 14. So if I do a peak, what's going to be 14? Yep, that's correct. If I do a peak right now, we have 14, the topmost of our book stack. And so right now, if I do a s dot pop before that, so now what's going to be our peak? 13. Yeah. So 14 gets popped out. So because it's last in first out, so the last value we entered was 14. It gets, now the last value is 13. If I do a pop again, 13 is going to get popped. So that's pretty much it for stacks. And for queues is like you can in for stacks, and the only difference is queue follows first in first out. So just say you enter a queue is the explain this is like an actual queue. You're going to a movie, you're waiting in a queue. The person who's at the front of the queue gets enter the movie theater first, and the person who's at the last place of the queue is going to enter the movie theater at the end. Same principle works here. So in queue, instead of like pop and push, what we call it NQ and DQ. So NQ is basically you're pushing values to the, and DQ is basically you're popping things out of the queue. So, and since queue follows the first in first out principle, whatever value you're at the end gets, it doesn't get popped out first. The value that you enter first, so like in a book example, when you do a pop, the book which is at the end is going to get come out first, because this is a queue, and queue follows a first in first out principle. implementation of queue is pretty much exactly the same as a stack, if you see. And so if I do a, so we have our enqueue function over here. So yeah, so enqueue is item, and the reason why I am not using append here, because what append does is append is only gonna enter the value at the back, but in queues we need it on the other side. So that's why what I'm doing is I'm inserting it at index at the front when I'm enqueuing it. And if I do a dequeue, so in a dequeue, since what I'm doing is like, since I'm to make it easier, since I just twisted the queue the other way around, when I'm dequeuing, I'm just taking out the last value out of it. And yeah, size is so right now the queue is empty. That returned the true. That's good. So queuing some values into it. So now these two values are inside our queue, and if I try, let's see here. Right now 1 and 2. Let's make it a little bit more. Yeah. So right now 1 and 2 are entered into our queue. So from this, like, and who can say like which is at the front and which is at the back? Like if I do a pop right now, like a DQ, yeah, number 1, yeah, because that entered our queue first. So yeah, I think that pretty much. I think since we're out of time, I was supposed to like code how it's gonna print out the first and last, but since we're out of time, I'm just gonna end this here. Sorry,
The peak function which we used in.
the peak, because oh yeah, it can work here, because since I'm inserting it in the opposite side, the peak can also work here. Yeah. So any other questions on this?
No, nothing here. Anybody else have any questions?
Yeah.
Awesome. Okay. Can you stop?
The recording? Okay.
Yeah, but leave it up.
The recording?
Yeah, leave the recording.
Okay.
Yeah. Are you muted? Do you want to mute?
Yeah, I think I'm muted. Yeah, I'm muted.
Awesome. Hi. Okay, I see some people thanking Sanjay. So thanks. Thank you, Sanjay. I thought the talk was actually really cool. I'm going to be doing the raffle now. We have a couple of items. Oh, you have a quiz too?
Yeah.
Sure. Do you want to share that?
Okay, so for like some Google swags, we set up like a small quiz.
Yeah.
So I have 5 quiz since we have a raffle as well. We'll do the raffle and 2 questions from the quiz.
Do quiz.
All quiz? Okay.
Yeah, all quiz. Okay. Hopefully you guys paid attention. If you send it in this chat, if you send it in this chat, I can post it in our Discord. So,
Oh, the quiz questions, you mean? Okay.
or is it like a Google form? Oh, okay.
Yeah. I
Okay.
can copy paste it too.
I see. I get it now. So whoever answers first.
Yeah.
Okay, I see. Okay, so whoever answers these questions first, from Sanjay, you can post in the chat. We also have 6 people here as well. Yeah. Sound good?
It's all gonna be like whatever I just talked about. It's not hard question.
It's not hard.
Okay. Because the first question is what type of today we talked about two main different types of data structures. So what type of data structure is an array? Yes, and is it linear or non-linear?
Linear.
You people have-
Okay.
Oh, so so we talked about arrays, right? Yeah. So my question was it a linear data structure or was it a non-linear data structure? Linear, yeah. So,
I think I think someone here got it.
okay,
Yeah.
let's
We have multiple stuff.
yeah,
Cool. Yeah. 1 point for someone here.
okay, so I'll ask you simple. So the peak function that we talked about in the stack, what does it show?
There you go. Sure.
Do we give no? Or do we do like points?
I think points.
Points, okay.
Yeah.
So
We'll say you have 2 points because you answered before, and then
Yeah,
each of
and
you guys have
1 point.
One. Sound
Okay.
good? And there's one person here that has 1 point.
Okay, yeah, so this is like just because this is also coding interview. So when I was talking about the coding interview section, like when you first start your coding interview, what is the kind of like in terms of big O complexity, what is the solution that you first present to the interviewer? Correct.
Okay, that's 1 point.
So, okay, so a stack is follows what principle? Life
First thing, last out.
a stack.
Yeah, first thing, last out.
Last answer.
Yeah.
First and first.
Yeah. Life of yeah.
Yeah.
That's 1 point. And they can use their mind. Oh.
Like you say the question, 5 seconds, and then
Okay, you guys wait for 5 seconds and then.
very slow.
Okay, so wait, what's the score? Like, how many more questions do you want me to do?
I don't.
You know what? Okay, I'll just do 2 more questions.
Sure.
You're at 2. You're at 2. You're at 1. You're at 1, right?
He's at 2, I think.
2. Okay.
2. Okay.
We need icebreaker. Okay. Let me just. Okay, I'll make this a little bit more into like data structures. So, like, just say you have your array. To insert an item at the end of the array, what is the time complexity?
And, okay.
So you guys 3.
Yeah.
No
Yeah.
time.
Huh?
No time.
Oh, time delay. We need the time. You know what? Let's just do that. So
Alternatively, we could just get everybody swag.
okay.
That is
Perfect.
also a thing too.
Wait, so whoever is here will give them the stickers. No?
Sure. Yeah.
And whoever came here, I think we'll give them all.
Okay. Yeah. I have some swag now. I can give you guys swag sometime this week. Does that work out? Yeah.
Yeah.
Okay. Does that work out with people online too?
Wait, so you
So who wants some swag? We got
are.
just a few sizes here. Yes, sir.
Oh,
I got it here.
so you got it.
You need
No. Yours is in my
Like,
car.
like-
Yours is in my car. I can certainly give it to you if you come with me to to my car or whatever.
Sure.
Yeah, okay. Awesome. And for you guys online, I will maybe quickly make a Google form. if you can hang on for like 2 minutes, then I can just grab your email and like a size. And then sometime this week I can email you, or I can meet you at like CSI desk or something here in Waterloo. And then we can exchange that sort of thing.
We don't have smalls, right, on this?
So I think we have everything of this. It's the black
It's
ones
the-
that are
Oh, yeah,
kind
yeah.
of funky sizing. Okay, give me like 2 minutes. I'll post a link in the chat and then you guys can fill it out. Okay. Thank you for joining.
The book, they follow this pattern.
Okay, hi. I just posted the link
Yeah, they
here.
all like part
If
of
you
the
fill it
same.
out and have your name and email and just pick a size, I can shoot you an email sometime this week and next week to try and like coordinate to get you guys your swag there. Awesome. Other than that, I hope you enjoy your night. Thank you for coming. Bye.